Welcome everyone here to our webinar today. My name is Florian. I work for a company called Intertrust. Actually, I had worked 15 years in the European energy industry, 5 years here based in Silicon Valley for a company called RWE, which then became Innogy, which is now known as E.ON. And I joined Intertrust 2 years ago. Intertrust is a portfolio company of E.ON these days and is dealing with energy data in the wider sense. And a very, very warm welcome today to Juergen Groenner. Juergen is the managing director of an entity called Westnetz GmbH, which is the largest distribution system operator in Germany. And Westnetz is also part of the E.ON group. Juergen is also a big expert in hydrogen, actually, because of the things he's doing today. And I consider him as one of the leading experts in this area. So we are happy to have you here, Juergen, today.
Yeah, very welcome also from my side. Happy to share knowledge and to get some interaction with all you and to speak about this fascinating topic of energy.
Yeah. Thank you. So what I will do, we run this as a fireside chat here, and I will provide a brief frame on the green hydrogen topic for maybe some of the people joining us today that are not super familiar. And then we will move into a fireside chat. So I have a bunch of burning questions I want to ask Juergen. And then if we have time, we can also do a bit of Q&A. I think there is like a Q&A tool on Zoom here where you can post your questions, and as the questions come in later on, we will try to cover them. So let me take a few minutes to frame the green hydrogen topic. The fireside chat, I've labeled that hype or hope. And why is that? So actually, if you follow the news, then the US government has released some goals that they want green hydrogen to cost less than natural gas in the future, to substitute natural gas in some of the use cases, apparently. So it's a pretty hot topic. California has announced that they want to invest 230 million only in California in hydrogen projects before 2023. The European Union is even more bullish. They want to invest more than 400 billion until 2030 to support achieving Green Deal's goals with green hydrogen. So, following these announcements, you see that this is a very, very relevant topic for all of us. And the question is, what makes hydrogen interesting? So if you look at it, it's a very flexible form of energy. It can be used in gas or in liquid form. It can be turned into electricity, or it can be turned into fuel. And if you look at the hydrogen economy that exists today, there's already a very significant amount of hydrogen that's being used today in manufacturing. I think it's around 70 million metric tons globally. But the issue is that this hydrogen is derived from fossil fuels, which is then called gray hydrogen. Or in some parts, the CO2 that comes with the production of hydrogen from fossil fuel is captured, and then we call this blue hydrogen. And of course, what we want is green hydrogen. And so where there is no CO2 emission in the production and consumption process of hydrogen. So the reason why this is such a prominent topic in the last months and also years is that the cost decline of renewable energy supports the business case for green hydrogen significantly, because green hydrogen is produced where electric current is used to split the water into hydrogen and oxygen in an electrolyzer. So you need low renewable energy costs from wind and solar to produce a green hydrogen cheaply. You also need good cost for electrolyzers, the hardware that is needed. And that has changed significantly, as we all know, over the last years. Green hydrogen, and that's, I think, a consensus between most of the experts that you can read, sees green hydrogen as an essential ingredient to meet the climate goals of Paris. So to bring the CO2 emission of the electricity, the transportation, and the heating and cooling sector down. It's also an important source for additional flexibility to the power and the energy system because it enables sector coupling. So what does sector coupling mean? It's the approach where we couple technologies such as electric vehicles, electric boilers, heat pumps, and electrolyzers for hydrogen production with the power grid. Remember, Juergen is in the grid business, so we are getting there. And these technologies that are then connected to a power grid effectively become components of this power system or power grid and provide additional flexibility like flexible electrical load to the power system and enable also the exchange of energy between the three sectors that I mentioned before: electricity, transportation, and heating and cooling. So this means that coupling of the electricity and the hydrogen sector are achieved. And this is why people in the electricity business, like Juergen and to a certain extent myself with the data and software angle, are very interested and see a lot of opportunities also in the hydrogen sector. So that's why we try to bring the two together. And in addition to that, hydrogen has also the potential to decarbonize difficult to electrify end-use sectors. Think about the chemical industry or big ship industry, where you can use hydrogen in the future to fuel cargo ships and so on. Aviation fuel is another use case. So a recent MIT research study that I found shows that the role of hydrogen interacting with the electric grid actually shows that holistic optimization of electric power and hydrogen supply chain infrastructure is favorable for emission reduction and decrease infrastructure costs. And that is very important because that's the hypothesis that people are operating under. And now there is like very fresh research from MIT, which supports this hypothesis, which is very, very important and relevant. The other good news is that hydrogen contains 3x of the energy compared to fossil fuels. So it's a very interesting energy asset. The problem on the other side is that the price of green hydrogen today is 3 times the price of natural gas in the US. So there needs to be a substantial decrease of the price per kilogram for green hydrogen, I think to a level around $2 per kilogram. Then it becomes cost competitive with other fuels. And I would like to close the framing. Overall, the research that you can find believes that there will be a substantial use of green hydrogen within the next 5 to 10 years. So it's still early days, but I think the expectation from a lot of participants in these markets and a lot of big companies have made very bold statements that they want to invest heavily into hydrogen is that this will gradually lift off in the not too long future out there. So that's a little bit the frame. I think it's important to understand where do we really come from here on the hydrogen side. So my first question to Juergen is a personal question. I know that you are personally very, very interested and very energized by this topic. Why is that? Give us your insights into what makes you so electrified by hydrogen.
My personal conviction is probably from a German perspective, but also from a European perspective, we will not be able to produce enough green energy by PV or wind, or it might be biogas, that can be, I would say, following the demand in Germany or in Europe. So this means if we would like to decarbonize all sectors, as Florian already said, there is absolutely need for us to import green energy. And by physics, there are some restrictions to do it via electrons over long distances. So there's a need to go in molecules, and these molecules could be in gaseous form, via pipeline transport, like we do it today probably from Russia or from Norway, or also from north of Africa to Europe, or in a liquid form, also via ammonia or methanol, or there might be liquid hydrogen, also a possibility in the future. So this is my main interest, that we see as an energy guy a strong need for imports, and therefore my background is also, I started in the TSO, so-called now TSO business, with long-distance gas transport, underground gas storages, LNG, and this kind of stuff. So there's a natural, I would say, bridge also for me, for my personally history.
Excellent. And so, you know, I talked about that hydrogen is around for quite some time. It's used, gray hydrogen is used in various production processes. So from your perspective, since when is the green hydrogen topic really on the agenda of government experts and also the energy companies? And because now there's a lot of buzz and noise about it, but since when do people really actively think about more the practical side of implementing such businesses?
I would say in general, since 3 years, I would say people are turning and are understanding that the all-electric world is not possible. But formally, also in Germany, the energy transition was first of all an electricity transition. So the thinking of the system as a whole, combining all sectors, also like heating and also the process industry and the transportation sector, this is only, I would say, 2-3 years now. However, we started with our first electrolyzer project some 7 years ago, but still had at that time a lot of explanation work to do.
That is a good point. You mentioned electrolyzers. So, I mean, for people who are not familiar with a large-scale hydrogen production, so how will this green hydrogen be produced? So, where does the electricity come from? Where will the factories be located? Can you walk us through that a little bit to give people the perspective?
Yeah, I would say, first of all, the target is to produce green hydrogen. However, the path to get to this target will be multicolor. There will be also the introduction of other types of hydrogen, like probably blue hydrogen, which we can produce from CH4 by separating, by steam reformation, the hydrogen, and put to a certain extent the C molecules into the ground and to store them. I think this is also needed to scale up the hydrogen economy. Furthermore, the main element in a total cost over 20 years is, as you said, is the cost of green energy produced by PV or wind. And so in the locations where we see high hours for wind or for PV over the year, this will introduce also hydrogen production there. It might be that we have a lot of projects now also in Europe, or especially in Germany, to start to understand the technology and to make the first steps. But I would say in the long run, this will be produced where we will have very good locations for producing wind and PV energy.
So that means, for example, in Germany, there will be like new hydrogen factories in northern Germany, close to the offshore wind farms?
Yes. Yes, this will be, I would say, a start. There's also what we call a German-wide hydrogen strategy, and they also the new government in Germany introduced a new target of 10 gigawatt to be in operation in 2030 for this. But in the long run, I would say the imports will be even cheaper due to the fact that I estimate that in other parts of the world, the producing of green energy by electricity is cheaper.
I think this is why countries like Saudi Arabia, a lot of sun, or Australia, a lot of sun, and maybe some countries in Northern Africa, I think, have some projects going on. Okay, so now the hydrogen is being produced in a windy or sunny area. So how do we get the hydrogen to the place where it can be turned into electricity or heat, cooling, or movement like transportation?
I think we can do some analogies to current gas transport. If we have the possibility to have a pipeline connections, probably like in Europe to Norwegian Sea, or to Yamal field in Russia, or to the sources in north of Africa, then the pipeline transport is the most economic way of transporting hydrogen in a gaseous form. If we go further down in distances, far more away and not reachable by pipeline, then we have three possible energy carriers. So it might be hydrogen in a liquefied form, but keep in mind, liquefied means it's minus 250 degrees. So it's nearly, it's really a challenge for engineering these processes. And the other way is probably ammonia can be produced relatively easy. Ammonia is NH3, so meaning you just take nitrogen and the hydrogen out of the production unit, and you form ammonia, which is liquefied, and you can transport it via ship. This is the easy side of the coin. The other side of the coin is it's highly toxic. So you have to take care in all the handling processes with ammonia. But still, in the first phase, you can take this kind of green ammonia as a green energy to replace ammonia, which is produced with gray energy. What is still open or the maturity level is not really advanced at the moment is cracking again of the ammonia in hydrogen at a later step. This will also need some more energy. So there are some other parts of, or some other possibility to transport hydrogen. It's called LOHC, so that you combine the hydrogen with a kind of an oil and then make it also as an energy carrier. But the maturity level of this is also very low at the moment. And you need also a lot of energy to get the hydrogen back out of the oil at a later stage.
And follow-up question, when you use the pipelines, I mean, is that possible, or do you need to upgrade the infrastructure? Because the reason why I'm asking the question, because somebody has to pay for that. And I think there is like hydrogen pipelines that exist today, but they're a bit different than the gas pipelines.
I would say from the transport level, first of all, the pipeline system is usable. The energy for transporting the hydrogen over the pipeline is introduced with compressor stations. And in these compressor stations are normally driven by gas turbines. And these gas turbines have to be modified to allow the introduction of hydrogen, because hydrogen has a different physical properties like a flame velocity and this kind of stuff. So the burning chamber as such has to be modified in a gas turbine that it allows the introduction of hydrogen. If we go further down the value chain in the distribution grid, it's mostly fine. It will work. Also, the thermal capacity of the grid is available to take all the load and the demand. At the application side, in the households, in the cellars, there is currently, from a technology perspective, a blending of up to 20% possible. Mm-hmm. And if we will go for 100% hydrogen, then we have to replace the heating appliances. Mm-hmm. So this is, I would say, from a technology point of view, it's fine. In a formal point of view, that you get kind of confirmation that your appliances will work, then we will have also kind of a discussion so that everything is allowed. Because we have a lot of different suppliers, and heating equipment is 40, 50 years old in certain areas. There we have to look very closely how to work with it.
Mm-hmm. That leads me to another question I have. From your perspective, what are the key bottlenecks today for hydrogen, and what are like the breakthrough innovations, if any, are needed to either expedite or implement it within like a 5 to 10 year time horizon?
For me, there's a key bottleneck probably in Germany is the availability of green energy to produce the hydrogen. So we have some 40% in the electricity sector, which is green, but it has also for sunny areas. If you speak in Germany about a sunny area, we have 800 hours a year. And if we have onshore wind, we have probably 2,300, 2,700, depending on the region per year. The business case is currently not given with these operating hours. And furthermore, if you make it all in a systematic connection with electricity and gas grid, we need at large scale, we need permissions, and permission procedure costs time. Mm-hmm. And this makes it at the moment, for me, that's the biggest bottlenecks. And on the other way around, we have I would say the political targets to be carbon neutral in 2045 in Germany. However, a lot of industries have much more ambitious targets, like to be in 2030 already climate neutral. This will give a huge dynamic into the market, and also the ability to probably increase the prices or to take higher prices for this. If we can make this sign on it, it's CO2 zero.
We have quite some experience, I think, in Germany, how to make the business case fit in case the technology and the levelized cost of energy are too high. So to bring them down. I mean, Germany has done that extensively in solar and wind. I remember a very famous CEO of a big energy company, I think in 2008 or 2009, was quoted in the Handelsblatt with the sentences, solar in Germany is like growing pineapple in Alaska. You know whom I mean.
Yes.
And so I think apparently completely underestimated the cost degression effects that would take place over time. But at that time, that was very true. And I think the government in Germany, the Red and Green coalition in 2001 actually laid the foundation for all the subsidy programs that then ran over 20 years. So my question to you is, do you think we will see the same happening for the hydrogen economy in the next, now with the new government, of course, but also like in the next 5 or 10 years?
Yes, what we expect is that there will be the introduction of learning curves. that will help to reduce the cost probably for the capex, for electrolyzers or for fuel stacks. But on the other hand, there will be a big question mark about the OPEX. What will be the cost for green electricity produced by sun and wind? So this is what I see as a big hurdle for the overall business case. The learning curves will be there. We saw for solar and batteries in the last 10 years some 35–40% of increasement. We expect it a little bit lower for all the hydrogen stuff, but my expectation is that we are for the moment too conservative. As you already said in your introduction, it might be Australia, it might be California, it might be Europe. Everywhere and everyone is thinking about hydrogen, and also the big majors are thinking about it. It's in each discussion we have hydrogen, and so my expectation will be that we could not prognose or forecast the learning curves. I hope they will be very, very deep, very sharp.
And do you think that we will see the same pattern that we start this hydrogen industry in Germany, for example, so on the hardware side, building electrolyzers, and then more or less the Chinese government decides this is like an interesting future business and takes over, which is exactly what happened in solar. So do you think
it's I would say a global topic? And as you already said, Australia is already on its way. And China will also take over and start with it. I think this will be a global competition to produce hydrogen. Sure.
Okay. So now let's assume we have, we've mastered these challenges mainly on the cost side. I think tech-wise, it's relatively clear what needs to be done. Can you talk us through a bit how the hydrogen sector will be combined with electricity, with the electrical system? So I mentioned this sector coupling topic, which is something that in the public debate, it doesn't exist. So I did extensive research. It's only really experts, energy experts, that talk about this. The role in supply side management for electricity, demand side management for electricity. And of course, that's something which is very close to what I'm doing, the data orchestration that we need in this super fragmented world with electricity and hydrogen, and everything has to play together. So give us your thoughts. How will this look like in 5 years or 10 years? What electrical system will we see at that time?
Yeah, what we will see, probably in Germany, we will see this high increase in electric cars. So we estimate 15 million in 2030. We will see, in addition, a lot of heat pumps to enter the heat market, especially for new builds. Furthermore, we will introduce renewables in the same amount in the next 10 years or 8 years only, which we have seen in the last 30 years. So this will make a lot of pressure and challenges for the electrical system. However, to store electricity, we see only batteries in the moment. If you look for it in a single view, and these batteries can help us for hours. But if we will have strong challenges to the energy system over the winter time, probably, also the efficiency of heating pumps will go down in case of low temperatures. Then the underground storages, which we have in place in Germany, which have around roughly currently will have a volume of 20% of the annual demand of natural gas, can also be transformed to take hydrogen. And then this can help to make us come through the winter and to introduce flexibility into the market. And on the other hand, if there are very sunny and windy periods where we could not, which will not match demand, so which will produce a surplus, we can also take this and produce hydrogen and put it into our storages. So this is the main idea of connecting both electricity and gas and hydrogen sector.
And so, I mean, that sounds like quite a major transformation of the existing system. What, from your perspective, will be the role that the regulators will have to play in Germany? But I think it's also in the United States, that's an issue because we are talking about a highly regulated industry. So is there like a new legislation required, or how are regulators involved in this discussion?
Yeah, currently in Germany, we have the situation that the transformation of the gas grids is in discussion, how to make it really, I would say, also from a social perspective, affordable. So, and by introducing these cost perspective from customer side of view, then a lot of people are saying, let's put the amount of money we need for the hydrogen transformation, first of all, to all gas customers, so that it's socialized, so that we can afford it. The other perspective is hydrogen and hydrogen grids are at the moment not a natural monopoly as a gas or electricity grids are. So why should we then put in any kind of regulations there? Let the market flow and that develop, and the best technology, the best solution for the customer will be highly competitive. So in Germany currently, we have both options. So if you are producing hydrogen in your plant and you would like to build a pipeline and connect this pipeline to the customer, you can decide by yourself if you would like to go into the regulation, or if you stay out of regulation and do it as an integral business. So, and my message would be, the regulation should be organized in a way that we support the scaling up of the hydrogen economy. And so I like this German approach, as it gives both opportunities to help scaling up the hydrogen economy. So it doesn't introduce any barriers or burdens at the moment.
Interesting. And so I read like the recent announcements also from E.ON, from the E.ON CEO, Leo Birnbaum, and others, that E.ON wants to play an integral role in that transformation. So how will this look like? Will you build new pipelines or retrofit existing structures or start selling hydrogen to companies? Can you share some perspectives how this will materialize for a company like E.ON?
Yeah, well, probably I will do it as with an example of a European project we are just about to develop currently. This is bringing in all the messages I've spoken earlier. We will partner up with Spain and Italy, and we will take Italy for producing green electricity. And we will take this green electricity by certificates to get it formally allowed, and will drive an electrolyzer in our region. and will then reach our customers. And we see especially also the small and medium enterprises that they need a lot of decarbonization solutions for them. Mm-hmm. And the other way around is we are with Iberdrola in Spain partnering, so that they will also take the chance of sunny areas and windy areas, will produce hydrogen, and will take this hydrogen with nitrogen to produce ammonia. And then we will ship it also to Germany over the Netherlands, go down the River Rhine and to our area. And then we will have also ammonia in our area. So we are just about to ask the market to specify their demand, and did the first feasibility stuffs and feasibility studies for tank and pipe and all this kind of stuff, preparing us for permission procedures and also looking for funding on a European level. Mm-hmm. So this is how we see the market will develop on first clusters, combining industry, combining heat market probably at a later step. Also what we see in communities is a high demand for transforming public transport or public, you must help me with translation, the big trucks which takes the waste out of the city.
Waste management. Yeah.
Waste and who cleans the street. These are trucks with heavy loads, and electrical driven does not work for them. And they also see a chance in taking this to hydrogen as a fuel. And we are also partnering up with these kind of car suppliers for these kind of special trucks.
Mm. So that's actually a good point. Transportation, electric cars. I mean, like hydrogen-powered cars are available for quite some time. I just read, preparing for this talk, that one of the problems is that in the US there are 43 hydrogen filling stations. Do you think there is a chance that hydrogen will play a role in cars, or is that?
My personal view is trucks, very heavy load trucks, as I said, for these special purposes, or trains. What it's relatively simple, but do not have it into your mind. We have roughly 40% of Germany trains are not electrified. They run with diesel. And the problem is, if you have some mountain areas, you have a lot of tunnels. And if you go through the mountain and would like to electrify the route, you have to expand the space, the tunnel space. And this is highly expensive. So it's much easier than to transform these kind of trains to use hydrogen and instead of electrify the whole train. So this is I see it in this heavy load and trains, and might be also in the maritime sector.
Mm-hmm. Excellent. So my last question to you before we go to the Q&A session: who will be the winners in hydrogen in 5 years? Get your crystal ball out and give me some countries or names of companies.
I would say if you are able to get locations which are very sunny and windy, and you get access to these kind of locations, and you have, I would say, good engineering and financial skilled company, then you will be on the winner side. And I think for Europe, you also have to go for big import contracts.
Okay. So I hear a lot of stuff that matches very well with E.ON.
Yeah, hopefully.
Okay, excellent. Juergen, it's absolutely fascinating. I think, I mean, for me, I'm aware of some of the projects, but not in that detail. So it was like very great to see that it's maybe much realer than a lot of people think. One of the issues when you follow LinkedIn, there are a lot of announcements like PR, hydrogen initiatives, but I think it's really great to get like a view under the hood, what's really going on. And I think what you described, what Ion is doing, sourcing green energy and then using that for electrolyzers in North Rhine-Westphalia or the Ruhrgebiet or wherever. I mean, that's like very concrete. So we have a few questions. If you have more questions, now is the time to post. And we have a very interesting one here from Edward. So Edward would like to know, from a political standpoint, as well as an energy business strategy standpoint, how soon could Germany's hydrogen production, green or otherwise, replace the Nord Stream system from Russia?
Just as I would say, will take 20 years. So just to make this, if you have a big pipeline, a pipeline is able to transport 50 billion cubic meters of natural gas. This is pipeline system. And the cubic meter of natural gas gets 10 kilowatt hours of energy. And what we now expect in the German national hydrogen strategy is 10 gigawatt of hydrogen production units. So it's far too low energy. So we need a lot of change for imports. Probably there will be in the future hydrogen be delivered through Baltic Sea or other pipeline systems which are already in place, introducing or importing natural gas at the moment.
Okay, so not a quick fix for the recent political issues around the Nord Stream pipelines. Then we have a question here from Sebastian. He wants to know if green energy is available. What are the best efficient ways to produce green hydrogen?
You put it into an electrolyzer, the energy, and we will have hydrogen on the other side. So we have very good experiences with these so-called PEM electrolyzers. This is a special technology which is already in place, and there might be some further developments, but I would say the electrolyzer is available. You can buy it, you can build it up to 2 gigawatt in size. It's there. And then we expect that this electrolyzers will be split in modules, probably 1.5, 2 megawatt per volume, and then you have it in a series.
Great. One question from Dimitri. That's an interesting one. What's the role of nuclear? So I assume nuclear electricity production to get green hydrogen, and he calls it pink hydrogen. I haven't heard that before.
No, we call it red hydrogen if it's from nuclear, but it's not really defines how to speak about the color. In Germany, we have stepped out of nuclear. Next year, all nuclear plants will be closed, shut down. But however, we see in the world there is still ramping up on nuclear. For me, it does not make really sense, because a nuclear power plant is mainly designed to run flat over the year. And I would put it in the demand curve so that it is serving the base load. And if you put it and produce hydrogen out of it, you have an efficiency topic. And what will you then do with the hydrogen? Put it back in the system for electricity or whatever. So it's depending on the system design. But first of all, I would take all the nuclear power to fill up the base load of my demand curve.
Yeah, that makes sense. It's an interesting aspect, actually, regardless from what Germany thinks about nuclear power. Another question here from Johannes. Besides the large-scale hydrogen game that will take a few more years to come, is there any real business case today for industrial and commercial customers to develop today?
Yeah, give you an example. We will have very famous German car manufacturers. The famous one is Porsche or Porsche. I don't know how we call Porsche in German. Porsche, and they have announced they would like to be carbon zero at 2030. So, and they have an own production of only 8%. If you look to the whole chain, how a Porsche is built, they do only 8% by themselves. 92% is done by all their partners within the supply chain. But the whole supply chain of Porsche has to be carbon zero at 2030. And this will introduce a possibility to increase the price for hydrogen and come into the business case, because I would strongly expect that these kinds of industry, probably these very luxury cars at the moment, that they are able to put the higher prices for energy also to the customer. So this brings the business case very short into the money.
Excellent. So I have two questions here from Beate. One is, how can the green hydrogen transition facilitate technology transfer and capacity building in renewable energy rich developing countries?
Yeah, just by partnering, partnerships, making big import contracts, and make kind of joint ventures where we have on the other one hand side you have these sunny areas or windy areas, and you will bring in some partners with probably more technology and more finance. Also, this is also finance skills to develop these kind of projects in a big scale.
And the second part of the question is, to which extent the green hydrogen transition or economy can support re-employing people that work in the fossil fuel sector today?
I think 100%. I think it's we have a huge demand for skilled workforce. And if you are able to work in a nuclear for the German case, or a coal-fired power plant, this kind of workforce is strongly needed also for all other kinds in the energy transition.
I think to a certain extent we saw this already in renewable energy in Germany, when wind started to lift off, a lot of the guys that worked in the conventional generation moved into wind, and wind was new, so there were no wind experts, so they became wind experts over time. They were like energy experts. I think also I read something that also the US government assumes that within a few years there will be 1 million new jobs or different jobs coming from hydrogen. So I mean, on the critical side, we had this job promise, at least on the hardware side for renewable energy, like 10, 15 years ago in Germany, where people said, we will have thousands of new jobs in producing solar cells and wind turbines. And at least on the solar side, well, these jobs are now in China and not in Germany anymore. So another question from Edward. What are your thoughts, Juergen, on the Airbus initiative, hydrogen for aircrafts?
For me, it's, I see it. It will come. And I think we are also in a kind of consortia with the Hamburg area, where we have set up a value chain coming from a Moorburg power plant, which will be transformed to produce hydrogen, introducing a small, I would say, hydrogen grid, formerly gas grid, and then we have applications there, and that might be also applications within Airbus. And I would expect then liquefied hydrogen will be introduced, especially if you just look to the I would say, demand to make flights over 4, 5, 6 hours and put it into as a dimension, what are possible alternatives. I think with batteries and their kind of heavy weight, it's very problematic. And the other solution could also be synthetic fuels, which could be introduced on the other way. But I really love this approach of Airbus to introduce and go with hydrogen.
Excellent. So the last 2 quick questions, and then we are at the hour. So Pedro is asking, actually, the risk of over electrification. So if everything gets electrified, could there be an increased risk globally for blacking out things if everything is electric?
Yeah, this is what I said. I think we have to explain from being a player in the energy market that we have always keep in mind that we have to see the whole system. It's not only electricity, it's also transportation system, heating and industry. And we have to make our thoughts about redundancies, storage, and the security of supply.
Yeah, and maybe one thing to add from my end, that's why you need a superior also data interoperability and data orchestration to combine all these things together in a secure way, that there's enough redundance and security built into the system, which is something that we sometimes don't see in the current system because people are operating too isolated because there is no data interoperability. And yeah, so the last question from Peter from Scotland. Are there any examples in Germany of sleeve PPAs for curtailed renewable energy to power hydrogen electrolyzers, or are these all private wired physical PPAs?
This I could not really answer. So we are just about to set up the first pilot projects with I would say 20 megawatt and more. And what I saw was this announcement probably of RWE and the big chemical companies that they partner up with offshore wind and make whatever connection over PPA or whatever to drive then the hydrogen. But I do not know anything which is in public currently.
Okay, excellent. So with that question, I would like to close. Thank you, Juergen, for your time. This was extremely insightful, extremely inspiring. I will write an article now on the data challenges around hydrogen. That's my output from this webinar, because I think it's really fascinating and interesting what's going to happen. Thank you to GABA for doing this together with us. And of course, thank you to all participants and all the people that asked the questions here. I hope you got good answers. If you would like to know more, reach out to us via LinkedIn. We will also post a video of this on the event side on LinkedIn, so people can share that or watch it, whatever you like. Thank you very much and have a great day. Have a good time. Merry Christmas. Stay safe. Don't catch COVID. Get vaccinated. Thank you very much.
Thanks for having me here. Bye.
Thank you.
Bye-bye.